In Kaggle, click on code. Once you click on code, click on new notebook.
Okay, sir.
So you can see, right? By default, it gives you Python. By default, it gives you Python. Now there are a lot of options here. Settings options. Click on settings. If you want, you can change the language from Python to R. By default is Python. But you want, you can change it to R. Okay, that is one. Now accelerator is where you have the GPU. Okay, we need to activate the GPU when you're running the deep learning model. So activate the GPU. Turn on the GPU. So 42 hours per month is what they are giving. Accelerator, tick mark GPU. Accelerator option. Okay, then go to edit. Not edit, 1 second. Accelerator option is not there. Huh? Okay. There must be something called in 3 dots it's showing. Huh? Where is the 3 dots? Okay, here, yeah. Click on, minimize it, and 3 dots, you should see the accelerator. Okay. Phone verification is required. Do the phone verification. You have to do the verification of your account. Mobile verification has to be done. Go to your account and do the phone verification. Online guys, you're getting it or you're not getting it? Got it? Okay, all of you have opened the notebook? Okay, click on add data. Click on add data. And then in search data sets, add data, chest X-ray, images, pneumonia. Chest X-ray images. Pneumonia, 5,863 images of two categories. Chest X-ray, COVID-19. I think this is chest X-ray COVID. Okay, check COVID-19 and pneumonia, this one. Okay, add 2.6 GB. Okay, check X-ray COVID-19 and pneumonia, 2.6 GB. Add the data set. Okay, chest X-ray, COVID-19, pneumonia. Now, move your cursor to the first cell, either click on the run or use shift plus enter. Move on the first cell. And click on shift plus enter. You will see all the JPEG images coming in, right? Got it? All of you got the list of all the JPEG images. Now go down to the next cell, import the libraries. Import TensorFlow, import Keras. Okay. Now, from Keras dot preprocessing, import image. Okay. X, we have to import the images. X underscore train is equal to image dot image data generator, rescale is equal to 1/255, comma, horizontal flip is equal to true, comma, zoom underscore range is equal to 0.2, comma, shear underscore range is equal to 0.2. So if you click on the data tab on the right side, if you click on the data tab, you will see the folder chest X-ray pneumonia. Data tab, not the add data tab. Click on the data tab, you will see the test, train and test folders. You have three categories: normal X-ray, COVID-19 X-ray, and pneumonia X-ray. So you can minimize it. We just need the train and test link. So, but first, create the image generator. We have to convert the images into pixels, right, for working on. So these are complex images. So we need to have this image data generator. We are rescaling the image to 255, 1/255. Horizontal flip is true. Zoom range is 0.2. Shear range is 0.2. Now we will import the data. X underscore train is equal to x underscore train dot flow from directory directory is equal to single quotes or double quotes, go to the data folder, okay, copy the file path of train data. You can see once you move your cursor onto the train, you can see the copy file path option. Okay, click on this and in directory paste the copy file path. Copy file path, comma, target underscore size is equal to 256, 256. Batch underscore size is equal to 1, comma, class underscore mode is equal to categorical. So x underscore train dot flow from directory is equal to copy the directory path of train data. Target size is 256, 256. Batch size is class mode is categorical. See, it says 5,144 images belonging to 3 classes. X underscore train is equal to, let me little bit on this one, so that all of you can see the complete code. Do it exactly same thing for test. First, define the image generator for test data also, and then flow from directory, import the test also. Exactly same procedure for test data also. Exactly same procedure for test data also. First, define the test. You can copy paste from the top. X underscore test is equal to image data generator command is same. So you can copy the image generator command, Control C, paste it and run it. X underscore test is equal to X underscore test dot flow from directory. Here we have to give the directory new path. Directory is equal to, go to the data test, copy file path, paste it, Control V, comma, target size is equal to 256, sorry, 256, 256, comma, batch underscore size is equal to 1, comma, class underscore mode is equal to categorical. So 1,288 images of 3 classes. Hmm. 256, what you call target size. Height and width of the images. These are 256 by 256. Your X-rays are very large, right? Earlier, we were dealing with 28 by 28, smaller images. They were converted into smaller images, but X-rays are bigger, right? So 256 length and 256 width, height and width. So X-rays are, these X-rays are 256 by 256, height and width. Those chest X-rays are large. If you are looking at X-rays of, take for example, dental, they will be 150 by 150. They are smaller, right? Or if you are taking X-ray of the palm or foot, they will be 150 by 150. Chest is a larger X-ray, right? You'll get a very big X-ray for chest. So 256 by 256, height and width. Okay. So we have imported the data. What are you getting? X test, that means spelling mistake. Check the spelling, your name, what you have given. Spelling mistake. X underscore test. Check both the spellings of both the image generator as well as flow from directory. You might have made a mistake. Okay, I'll come. Wait. Okay, let us import the functions from Keras dot from Keras import sequential. Sequential is for model building. From Keras dot layers import convolution 2D, comma max full 2D, comma batch normalization. From Keras dot layers import dense, comma dropout, comma flatten, comma activation. So we need to import it. Corrected it? X test, if it's A, X test is wrong. You have very small x underscore that somewhere. First, you can define where is image better than you have directly defined the flow directly. Where is this image better? Without defining the image generator, how is it defined in the flow? Okay. Online guys, all of you got this?
Yes, sir.
CNN is equal to sequential CNN dot add convolution 2D 32, comma 3 by 3 kernel, comma activation is equal to ReLU, comma input underscore shape is equal to 256, comma 256, comma 3, comma padding is equal to same. CNN dot add batch normalization CNN dot add convolution 2D 32, comma 3, comma 3 activation is equal to ReLU, comma padding is equal to same. CNN dot add dropout 0.20. CNN dot add convolution 2D 24 3, comma 3 kernel activation is equal to ReLU, comma padding is equal to same. We will define another convolution layer with 64 and 3 by 3 kernel. Convolution, so CNN dot add max pool 2D pool underscore size is equal to 2, comma 2. CNN dot add dropout 0.20. CNN dot add flatten CNN dot add dense 128 activation is equal to ReLU. CNN dot add dropout 0.30. CNN dot add dense 3 activation is equal to softmax CNN dot compile optimizer is equal to Adam. Loss is equal to categorical underscore cross entropy, comma, matrix is equal to accuracy. CNN dot summary. Spelling mistake. One crore, almost 13 crore, 42 lakh, 49,339 weights. You can imagine the model thing. This is the model. See, I told you now, max pool will be always two-dimensional. That we did not average pooling and max pooling. It will be most probably two-dimensional. And the filters will always be 32 and 64. We rarely go to 24, but here we went to 24 also, but generally it will be 32 and 64. Generally by what these values are defined by the people who created the CNN algorithm. They decided it will be 32, 64, worst case scenario 24. But most of the times we use 32 and 64 with a 3x3 filter, 101010 and this thing. Or RGB filters are there, which are, if it is a color image, you have RGB filters. They are different numbers, but they are also 3x3. This is a black and white image, right? So this is not a color image. So generally the filters, the kernel filter size will be 3264 only with 3x3 as the base kernel. Now there are advanced models like VNet. There are other CNN versions also. VGNet, VNet, and all these things are there, which are developed by other researchers from the basic CNN. There you might see 128 also as a filter because they use a lot of computing power. But here we are using 64 and 32 only. Now it all trial and error. We will run this model. We will get an accuracy or not. Then we will play with the kernel filters and then see how our accuracy will improve. Because look at the weight, 13 crore weights means it's a very, very large network because the images are large. You can't do anything because the images are very, very large. If it is smaller images, like yesterday we went with 8 lakh weights or something like that. So this is a very large network. Weights. Yeah, when we did the calculation, we had only 9 weights, right? 6 input, 3 output. So these are the weights for each layer. You can see here, total weights are like this. But the first input layer, it's all less, see here. By dense, it's coming around 13 crore. Dense itself is becoming a very large layer. So this type of networks, they are very, very complex and they are very, very, what you call, requires computing power to work upon. Once all of you are done with this, you can run the model. Guys, you can run it cnn.fit x_train epochs is equal to 10, batch size is 128, validation data is x_test. cnn.fit open bracket x_train comma epochs is equal to 10, batch underscore size is equal to 128, validation data is equal to x_test. 30% features we are dropping down and irrelevant features. Yeah, 4 minutes. Yeah, because I told you, it's a very large network. On GPU only, it will show you a very large thing because it's a very large network. Okay. Spelling D capital. Did you import it? Then it's a spelling mistake. Yeah. X underscore train, comma, epochs is equal to 10, comma, batch underscore size is equal to 128, comma, validation data X underscore test. You gave directly, right? X test. Yeah. You want the code, yeah. Yes, I've emailed. Without GPU, one epoch will take 20 minutes. That is the problem. And see, it is going by images, so it has to go by image. You can take. No, validation accuracy is how much? Yours? Random, no? There will be some randomness. So overall it will correct. Algorithm. Gradient descent algorithm is the fundamental algorithm in derivative calculus. Reduce the weights. See, you know solver in Excel, right? That also does the trial and error. Wherever you have this trial and error method, we do randomly choose a number, calculate an equation, and then we reduce the value by a little more and then recalculate the equation. Thereby, if it works, then we go by reducing smaller proportions and then we reach our goal. Trial and error methods in calculus and statistics. So same thing here. So what gradient descent algorithm says is reduce the weights in smaller proportions over multiple iterations. And as you reach the local minimum, reduce the weights in even smaller proportions. Otherwise, what will happen? It will jump onto the other side of the curve and it will start pushing up the error. Here we are trying to reduce the error, right? If you do it in large quantities, it will jump to this side. If it does something, it will push the error. That is the gradient descent algorithm. Now, there are many types of GDs. One type of GD is Adam, which we are using. Here, we are using the Adam optimizer, right? So the Adam gradient descent, the formula is, this is the formula. Regression, the word regression is there, right? It is also type of regression, but the only thing is it is predicting non-numeric variable. Linear regression is a regression model that predicts numeric variable. Logistic regression is also a regression model that predicts non-numeric variable. Equation is same, right? E to the power of intercept plus beta 1 x1 beta 2 x2. Both are regression models only, right? But one predicts the numerical continuous, the other predicts the non-numeric binary or multinomial. Here, this is the Adam algorithm. While the weight do not converge, step 2, calculate gradient GT, derivative of x comma y by what you call this one? No, d by dx, now what do you call that? Do only. No, yeah. D by do only, yeah, do only. Calculate PT is equal to M1 into PT minus 1 plus 1 minus M1 into GT. Why partial? So this is how this works. It is also gradient descent, but it uses a little bit different version. We call it as adaptive momentum. We call it as adaptive momentum. See, all of them are basically GDs only. Stochastic gradient descent, Adam. These are all versions of gradient descent, but slight difference in the calculations. This is called, Adam is called adaptive moment gradient descent. It adapts to the changes. It's a partial differentiation calculus. Whereas gradient descent uses derivative calculus. You know, right? That straight line. This is what slope, what we call it as calculation of the slope, right? Toward to the line here. This is how we do now, we gradient. So these are all same, but why we are using Adam? Because it is high end compared to the gradient descent. It adapts according to the data. And we are dealing with complex images. This is the problem with image processing. You have to be patient. You have to have algorithms correctly defined. Otherwise, your accuracies will change. Take a break. No problem. Till it runs, you can take a break. Okay. Yeah. So ResNet is a model developed by Google guys. Again, this is the architecture of a ResNet. It is very complex network, which is built on the VGG19 model, where you have 7x7 convolution 64, 3x3 convolution 64. See how many layers are there. Look at the layers, and then each layer will have multiple convolutions and all. And then finally, the neural network would be fully connected network would be 1,000 neurons, here also 1,000 neurons, and here also 1,000 neurons. 4,096 neurons, 4,096 neurons, and 1,000 neurons. This is the VGG network. This is the VGG19 network. This is the ResNet 34 plane, 34 layer residuals. 34 layers are there. This is a very advanced model. Now, I have run the ResNet on the skin cancer lesion dataset. This was done for faculties of an engineering college last year sometime, where we identified the skin cancers. So skin cancers was identified using fast AI. We have used fast AI. Skin cancer data, multi-class, melanoma, keratosis. So different types of cell cancers were there. And then we have done the ResNet this thing, and we got fairly good accuracy. We got fairly good accuracy on this model. So these are advanced models, ResNet, VGG and all, GoogleNet and all, which are very advanced, which require a lot of computing power. They are very powerful models. So CNN is the base model. What we are discussing is the base model. As of now, we'll be, as part of the curriculum and all, we will be knowing only the base model. Okay. Now, the next type of neural networks, which is widely used, is RNN, recurrent neural network, RNN. Recurrent neural networks. These are the second type of networks which are widely used. Recurrent neural network. So recurrent neural network works on sequential data. The data must be sequential. Recurrent neural networks are designed to work on sequential data. Sequential data, classic example is time series. You have a sequence, right? Day wise, you have to go with the date wise. You can't go with any other sequence. You have to go in a sequential. Temperatures data, traffic data, these are all sequential data. So RNNs, recurrent neural networks, are designed to work on sequential data. A simple RNN model looks like this. So what you observe is the output layer to hidden layer is what the action happens. Once the output is not properly done, it goes back to the hidden layer and then the hidden layer will process. Not unlike in your normal neural network where the backward propagation goes into the input layer also. Here, everything gets stuck at the hidden layer. Every processing will be done in hidden layer. Or if you want me to show you another diagram, so you can see here, the backward propagation is through time. Backward propagation is through time. Whereas in a normal neural network, there is no time variable, so it doesn't go with the time. So here we have to reshape the data also here. Take, for example, you will take last 10 days data to predict for tomorrow's. Similarly, you will take previous 10 days data to predict yesterday's. Similarly, you will take the previous 10 days data to predict day before yesterday. So like that, a time variable will be there, and then you have to restructure your data in that model. The independent variables will be the historical time data. Whatever values you are taking, whether you want to take past 10 days data or 50 days data, you have to decide, and then it will be taken. So in recurrent neural networks, are basically for sequential data. So basically they are for sequential data. Now, examples of sequential data are time series data, autofill. You have this autofill, right? It's again sequential data, autofill. Based on the last two words, you have to decide what will be the next word. Similarly, search optimization, Now, if you're searching for one thing, automatically recommendations come for searching for other things also, right, in the side, right? So all those things, Google, Facebook use these recurrent neural network algorithm to predict basically sequential data. Even grammar checking is also sequential data, right? There are fixed rules for grammar. Verbs, pronouns, adjectives have to follow a certain sequence, right? So sequential data is also about your grammar check, is also your sequential data. So here, the RNN output is dependent on prior elements within the sequence. Within the sequence, it follows a particular sequence and uses the prior elements for prediction. So time-based backward propagation. Backward propagation through time, BPTT, is one of the feature you can see here. So updating weights in the recurrent neural network, the BPTT algorithm updates the weight in the neural network based on the time dependency. Based on the time dependency, it will go take the what to call the updation of the model or the weights. One of the popular RNN models is LSTM model, which called long short-term memory model. LSTM, long short memory network model. Long short memory network model. So this is the model, LSTM model. You have to go for a bigger model. That is very slow. So these are the various equations it uses to calculate the LSTM. So it will take the previous outputs, the T minus one, previous output, previous data as inputs, and then it calculates FT with a sigmoid activation. Then it will calculate CT with tan H activation. Then it will calculate LT again with sigmoid and OT with sigmoid. And HT will be the multiplication of OT into tan H. So XT is the input vector. HT minus 1 is the previous cell output. CT minus 1 is the previous cell memory. HT is the current cell output. CT is the current cell memory. So this is a long short-term network model which is there. Now I will explain you the various steps involved in the LSTM model. So in LSTM, errors are backward propagated through time and layers by maintaining a constant rate. By maintaining a constant weight rate, the errors will be backward. LSTM stores both the input and output of network in memory. It will store the inputs as well as the outputs in both in the memory. The activation functions that are used are sigmoid and tan H. The activation functions that are used in the network are sigmoid and tan H. Now, different data blocks are stored in cells of network. Different data is stored in blocks. Now the input gate and the output gate extract and store useful information and deletes the irrelevant information. So the input gates use sigmoid, the output gate uses tan H. Input gates uses the sigmoid, output gate uses the tan H. You can see here different formulas are calculated. And then the input uses the previous data, and then it passes them through different activation functions. In normal networks, we had only one activation function. In convolution, we have different convolution layers. So here, these layers, the FT, CT, LT, and OT, in one single block is one layer. Like we have the convolution layer, right? One convolution layer is equal to one block. The diagram is one block. Like that, we can have LSTM multiple blocks. In a single block of LSTM, you will have this is one layer. As if I want me to tell you in the easiest terms, this is one layer. In convolution, we have different layers, right? Convolution 2D, 4, we have 32, 33, 64 like that. And this is a single layer of one LSTM. Each LSTM layer will have these functions, the FT function, CT function, LT and OT functions. This is one block of LSTM. We call it as block. Like that, you can define your own LSTM blocks. Now, what you can define, how many days data you can take. Do you want to take last 50 days data, 20 days data, or 30 days data? Accordingly, you can define your LSTM block. But the functions are fixed. The formulas are fixed. Whatever data passes through the same fixed formula. FT, CT, LT, and OT. The only thing you can define is the T minus ones. T minus ones means prior. How many days prior you want to take the data as input and then predict it on Y. So this is the structure of an LSTM model, which is used in sequential data, okay, to predict, right? We have Yahoo Finance. No. Okay. Pip install Y Finance. Import Y Finance as YF. You can, Yahoo Finance gives you the data of any stock prices of US, Indian, and European markets. Indian markets also you can download the share price, European markets and US markets of company share prices you can download. You can also download the prices of Bitcoin, prices of gold, price of crude oil, all those things can be downloaded. Let us use Bitcoin. Bitcoin is equal to YF dot download. The code is BTC hyphen USD, comma, start is equal to, we will take 5 years data. Today is what? August, right? 2017 hyphen 08 hyphen 01, comma, end is equal to 2022 hyphen 08 hyphen 20, comma, progress is equal to false. So Bitcoin dot head. So we have from 31st July 2017. Okay. And then tail. See, you got the data till 19th, Friday. You can plot also. Bitcoin dot plot kind is equal to line. Bitcoin dot which price? No, we have to choose the close price. So you can see the Bitcoin price, how it drastically went up from 2021, and then it is falling again. This is the Bitcoin price. You can plot the line plot. नहीं बढ़ेगा because क्या कि governments are launching their own bitcoins ना. China has launched its own bitcoin. RBI भी रुपये का bitcoin launch करने वाला है. US डॉलर भी bitcoin में आएगा. बाइडेन अगर ट्रम्प होता तो अभी तक आ जाता. तो डिमांड कम हो जाएगा ना इसके लिए. तो when demand falls, price will automatically fall. Earlier there was nothing. Huh? But see, earlier only Bitcoin था, इसलिए इतना डिमांड था. बट उसके बाद बहुत से कॉइन्स आए थे ना, एथेरियम आया, डॉट्स कॉइन आया, तो देन डिमांड वेंट इनटू अदर कॉइन्स आल्सो. एथर आया, तो अभी क्या है कि देयर इज नो, द ओनली रीजन व्हाई इट वाज द ओनली वन लीगली अवेलेबल एंड इजीली भी सोल्डेबल. अगर आप ट्विटर या इधर बेचना चाहते हो ना, बहुत मुश्किल है. Whereas Bitcoin you can sell very easily. अभी बाकी के कॉइन्स बहुत कॉइन्स आ गए ना, अभी कुछ अभी बंद हो गए. RBI is planning to launch India's Bitcoin sometime in 2024 or 25. वो they are waiting. India कभी आगे नहीं बढ़ता ना, दूसरे को देख के ही we have to follow. We are the followers, right? So we are waiting when US will launch it. US का देख के फिर हम लोग डिसाइड करेंगे. या जापान लॉन्च करेगा तो उसका देख के we will wait. Because we don't have that blockchain structure, na. RBI is not technically that competent. So अगर कोई other central bank जो developed nation say if they do it, then we will also go and do it. Okay, so we need to reshape our data. Import NumPy as NP. DEF sampling sequence comma n underscore steps colon capital X comma capital Y is equal to list comma list for I in range length of sequence SAM is equal to I plus n underscore steps if SAM greater than length of sequence minus 1 colon break X comma Y is equal to sequence square bracket I colon SAM comma sequence square bracket SAM. We have to further do it. X dot append X, Y dot append Y, return np dot array of X, comma np dot array of Y. See, basically what we are trying to do here is see, we have data like this. 100, 200, 300, 400, 500, 600, 700, 900. We want to predict the next value. Okay. So what you have to do is you have to restructure the data like this. 100, 200, 300, Y will be 400. 200, 300, 400, Y will be 500. 300, 400, 500, Y will be 600. This is the type of data resampling we are doing. See, this is our data. We have data from 100 to 900. Right? We have to predict what comes next after 900. To predict it, we have to create X and Y, right? So X will be 100, 200, and then so that is what we are trying to do by creating this function. The one sampling we are trying to do is we are breaking the time series data. We have it in single column, the close price in single column. Now we want to break it into X and Y. Now what will be X here? N underscore steps. Let us say I will take last 10 days, we will take last 10 days prediction, we will take. X comma Y is equal to sampling Bitcoin dot close price dot to list to underscore list comma N underscore steps. Okay, so for I in range length of X colon print X square bracket I comma Y square bracket I. See here, it takes the last 10 days prices and this is the dependent variable. Okay, and then it goes from 2788. It see, it starts from the next value and then it will take the next price. So previous 10 days, at every day, we're using the previous 10 days to predict the next. Previous 10 days to predict the next. So this is the data structure we have to create. Because in time series data, we have only one column of data, right? Close. Univariate time series, we have only one data. And then we are creating a X from that data only, which is the, here I have taken 10 days. You can take your choice, 20 days data, 30 days data, whatever data you want, you can take. Your choice. So basically the sampling which we are done here is this. The sampling thing which we are done is this. We are converting the data into X and Y. where X will be the last 10 days and Y will be the current day's price. Got it, all of you? What is the error you're getting? Okay. What has no attribute array? You have not imported NumPy as NP. What doesn't have array? NP dot array. It is not array. Spelling mistake. Huh? What you got? For you. Then formatting error. Check the indentation. Return should be outside to the fur. Return should be straight to the fur. Got it? break current. Okay. See, this must go up. If faster than it's less. So that. Oh, indentation. This should be in the same line. Okay. Scroll it up or down. Here. Down, down. Right? Okay. So this is C. That's what now we are taking the last 10 days to predict today's value. Today's value, last 10 days. Indentation error, I'll come. From Keras is not active. Import TensorFlow. Import Keras. Whoa, why it says TensorFlow and Keras is not there? Pip install TensorFlow. You also got the error, no module? We didn't do it here, right? Okay. वो स्ट्रेट में रहना है जब आप लोग स्ट्रेट आओ सो कंडीशन स्ट्रेट में ये जो एक्सपर्ट है ना फॉर इनके लेटर को बाहर के पास जो भी है सीक्वेंस में देना पड़ेगा। हाँ, नहीं तो एक बार उसको स्टॉप करके, हाँ ओके, तो आप किसी को एक को स्टॉप करो। नहीं नहीं, ये है ना स्टॉप, रन के बगल में स्टॉप। अरे यार, कर्नल डेड कर्नल हो गया है, क्या हो गया है? कर्नल restart and run all. Why it says restart kernel again? TensorFlow क्यों काम नहीं कर रहा है? It's a little bit larger library, 240 MB library, image processing का library है. It's a big library. Oh, why it is saying like this? It is asking to create a new environment and then install. You also getting the same error, kernel died error? No, you are not getting, right? That's a Mac problem. For you it is working, import TensorFlow. M2 का प्रॉब्लम चल रहा है, फिर M2 का कौन रेक्ट करेगा यार? Okay. For me it is dying, kernel died again. Okay, for you it is running, right? So no problem. Let us continue. Okay. Now, once you have installed TensorFlow, you have to run these commands. You have to first reshape the data. X is equal to x dot reshape, open bracket, x dot shape, square bracket 0, comma, x dot shape, square bracket 1, comma 1. Reshape it like this. So from Keras, because input shape you have to give now. In the model, you have to give input shape, right? 50, 1. Earlier, it was like this, right? Now we have reshaped it into individual arrays. For processing, na? Earlier, it was like this. See, this is your X. It was like this, array with dependent variable. We have made only independent variable here. There is no dependent variable here. There is only X. That's what we need now. We need X as separate, Y as separate. So we are separating X and reshaping it. From Keras, import sequential. You could import both TensorFlow and Keras. Yeah. From Keras, dot layers, import LSTM. From that's what na Mac में वही problem हो रहा है. So what we have to do is download the notebook and open in Google Collaborator. Mac में problem है. Mac में we have to create a new environment. उसका बहुत लंबा process है. And then we have to install all the libraries and all. वो 1 घंटा लेगा अभी. पूरा एक नया environment create करना पड़ेगा. Anaconda Repository में default environment आपको root दिखाई देगा ना. So in Anaconda we have this base root. So you have to create a new environment here. तो यहाँ पे new environment create करके उसमें Jupyter, Pandas, Python सब packages करके we have to install TensorFlow and all. First install TensorFlow and Keras, and then relevant pandas, numbers up in Kannada. It will take time. Instead of that, use Google Colab. Download the notebook, import it into Google Collaboratory, and then run it there. Okay, dense. Kernel is restarted. Model is equal to sequential. Model dot add LSTM open bracket 50 comma activation is equal to ReLU comma input underscore shape is equal to 10 comma 1. Model dot add dense 1. Model dot compile optimizer is equal to Adam, comma loss is equal to MSC, mean square error. Model dot summary. Check the model summary. You got the model summary? How many weights? So model dot fit x comma y epochs is equal to 50. Model dot fit x comma y epochs is equal to 50. Run it. It's running. How much you got? Accuracy. Sorry, MSC. Square root of that MSC. You might have got MSC, right? MSC you didn't get? Mean square error. Here, model dot fit x comma y, capital Y, right? Epochs is equal to 50. You're getting the loss, na? You got the loss, right? Okay. So NP dot SQRT so 1350 is the RMSE. RMSE of 1350. Mean square error. We have defined the loss as mean square error, right? Mean square error. Loss is MSE, mean square error. Square root of mean square error is RMSE. So y underscore thread is equal to model dot predict x. Okay. 1 second. PLT dot plot y underscore thread. Import matplotlib dot pyplot as PLT. PLT dot plot of y. Both are almost similar prediction we are getting, right? See, you can see the blue line also in the back end. Orange and blue, both are there. PLT dot legend. Legend. Okay, but you can see both the lines overlapping, blue and orange. You can see the blue line slightly in the back end, right? They're overlapping. One side is not followable. Why? Done? Yeah. You might have missed running one previous step. Can you maybe? Yeah, how to add legend to this graph? Just check. PLT dot legend y underscore thread comma y. PLT dot show. Legend नहीं ले रहा यार. Why it is not taking legend? कलर चेंज कर सकते क्या? Only minor changes are there. See, you can see that the thickness is changing. But it is almost closely predicting, na? Only 1350 is the RMS. We'll give y here and y underscore red. Now you can see the blue and the orange lines, right? Y and the y red, right? We can see the y red is orange line, blue line is the actual line. So it is almost closely predicting. Remember this because we are seeing in some companies they are sending you the classes. That's what they should want to say in the right? They have neural network with us. When they say use neural network to predict, they have to use LSTM. So this is very close prediction. Run and LSTM with coin. Okay, and then we have given some images, right? Code, not code. Text. All right. Okay, so file download IPNB file print save Okay, guys, I've sent you the notebooks. Any doubts online, guys?
No, sir.
Yeah. So we'll end the session for today. If you have any doubts, you can ask me in the next session. Okay?
Okay.